Okay, so this is a follow-up to problem 1, which is from section 11.6, page 187 of the SAT review book from Whitehall Publishing. So basically, the way you do this, like I said, you need to find what this vertex value is in x and y coordinates. And then once you find that, you can very easily find what the y-intercept of this line would be, which would be right here, because you just have two points of that line, one of which both of which also happens to intersect parabola, and then you can just use point slope form to find what that equation would be of that, what the y-intercept would be actually of that line. The equation of the line, then the y-intercept. So the first thing we're going to do, this is another format for parabolas called intercept form I found from online. And the point of this is that we have two x-intercepts, right? So I'm going to plug that in here. Well, I mean, we know A is like the kind of the constant, or I guess you can call it the steepness constant or coefficient to the parabola, which we don't know, but we can find what the x, let's call that V vertex of the x value. It's actually just going to be the midpoint because of the symmetry rule with parabolas, that the vertex is always at the x you can draw a vertical asymptote of symmetry from which both sides of that parabola will be symmetrical, of course. So that the x value of the intercept will simply be the midpoint. So it'll be, let's call that x1 plus x2 divided by 2. So this will be -4 plus 2 divided by 2, which of course is -2 over 2, which of course is -1. So this vertex value, the x value of that will be -1, and then whatever the y is, we don't know yet. To find what the y value is, we can plug in this, I believe both of these, because this was what makes the y value 0, right? So the p and the q. So q is basically -4 and 2. So y equals, the equation for this parabola can be represented by a times x minus -4 times, it's kind of like, these are both the x-intercepts, because whatever that intercept is, when you plug in that value for x, if you plug it in, it'll make this 0, which will make this 0, which will make this 0, which makes it an x-intercept, of course. X minus -4 times x minus 2. To simplify, that'll be a times x plus 4 times x minus 2. So we're very close to finding what the y value would be of that vertex, because we know that the vertex is, now we just have to know what a is, which is a constant, which we don't know yet. But if this is, I'll call that y. So to find that, I was thinking of how to do that. If we're at -1, I mean, one way you can do it is, I guess you can just kind of guess. Unfortunately, I don't know, but there's a better way to do it. Just kind of guess values for a. Maybe if a was 1, and see if these values are satisfactory. If a equals 1, assume a equals 1. So then basically y, to find what the y value is, we just plug in -1. Well, we have this value to test it against, so we can plug in 0 and see what we would get. If we see if we get 16/3, we would need 16/3. Oh, actually, we can plug in that. Okay, not assume. We can actually just plug in that value directly, because we can say that 16/3 is equal to a times, and then x equals 0. So a times 0 plus 4. There we go. 0 minus 2. And then from there, it's pretty easy to find what a is. Remember, a is that constant, that, or coefficient to the parabola, that, not the x squared of the parabola, but the parabola in this standard format, which is a different form, that kind of affects the steepness of the parabola. So if we solve for that, we'll have 4 16/3 equals 4 times -2 is -8 a. If we multiply both sides by 3, we'll get 16 equals negative, what would that be? 24 4a. So a looks like it would be negative 1/3. 16 divided by negative 24 is negative 1/2, actually, excuse me. 2/3. So that's what a, that's how you would find what a is for that. And then we can so now we kind of have our entire quadratic equation squared away. So then we can find, so y is, so if we plug in, again, we're going to plug in negative 1, as we found earlier, the y value of the vertex, which would be negative 1. Okay, so we're going to plug in negative 1 for that and then we'll find what the y value is. So if x equals negative 1, y or actually vy, we'll call that vertex value, y value of the vertex is equal to negative 2/3. I'm just going to verify that. Negative 24, yep, it's 2/3. Negative 2/3 times, and then it'll be negative 1 plus 4 times negative 1 minus 2. So doing that on my calculator, I'm going to get, I'm just going to plug it in my calculator directly instead of doing it by hand. So that would be negative 3 times, also negative 3. Positive 3 times negative 3. Let me simplify this. Negative 2/3, 3, and then negative 3. So 6 exactly. Okay, so now we have that point figured out. So this will be 6 exactly. So now we kind of know, okay, here are the 2 points on this line. So to find the m of this line right here, I kind of drew a little beside it, but that linear line crossing the parabola, this will be, of course, with the y2 minus y1 over x2 minus x1 given. So we have the point negative 1 comma 6 and 2 comma 0. So it's pretty easy now to find what that y-intercept would be. Basically, m is going to be 0 minus 6 over 2 minus negative 1. So we have negative 6 over 3, which is just negative 2, which makes sense because it's going it's decreasing as x increases, so it should be a negative slope, of course. So to use that in our point slope equation, we'll just use this 2 comma 0, so y minus 0. Remember, point slope form is y minus y1 equals m times x minus x1. Point slope form of linear equations. Okay, so that would be equal to negative 2 times x minus 2. So y equals negative 2x plus 4. So the answer should be 4. So that would be B, which is y-intercept, of course. Oh, didn't I? Oh yeah, 4 is one of the options. Okay, I'm going to check the answer to that right now. Really quick. Okay, so okay, that's what I got. And this is section 11.6, problem 1. I'm gonna give some explanations here. Oh, it's actually supposed to be C. Okay, let's go back. Probably mistaken my math. No, C, that's right. There we go, 4. That is the right answer. Right here, they get 4. Yes, they do. Same answer as me. Perfect. So that's how you do that. To summarize, basically, you have to be aware of this intercept format for quadratics, and then you have to be able to apply that to find these p and q values, and also to find the vertex value of x, which is the midpoint. So you have to recognize the property of symmetry with regards to vertex values and parabolas. And then you also have to recognize that you can plug in a point at x equals 0 because you have the intercept. You have one of the points on the parabola, which happens to be the y-intercept of the parabola. So then you can plug that in to find what the a value is, which is a constant. And then from there, you can find what the value of the vertex is, which is 6. And then from there, you can plug in those 2 points you have along that linear line to find what the slope is. And then from there, you can use point slope form to find what the intercept will be, which is 4.